The trick to solving a problem like this is to realize that you need to get everything in terms of sine or cosine. One or the other, not both. So what I'm going to do is when I see a squared, I'm going to substitute using the Pythagorean identities. So here, I'll write it over here. Here's what I mean. I know that cosine squared plus sine squared is equal to 1. So let's say I've got a cosine squared over here, which I do. What I'm going to do is I'm going to solve it for cosine squared. So that gives me 1 minus sine squared. And I'm going to take that 1 minus sine squared and I'm going to stick it in here. Now what that's giving me is all sines. Okay, so that can be like my variable x when I do my factoring. And so by eliminating that cosine, what I can do is I can rearrange some terms here. So I can go like this. We'll go negative sine theta squared plus sine theta plus 1 minus 2 is equal to 0. So that's negative sine squared theta plus sine theta minus 1 is equal to 0. Multiply everything by negative 1. So that's going to give me sine squared theta minus sine theta plus 1 is equal to 0. Okay, so now what I want to do is either try to factor this or use the quadratic formula, or something of that nature. Okay. So now to solve this, I'm gonna rewrite it like this so that you can see it a little bit better. This is x squared minus x plus 1 is equal to 0. So I'm looking for solutions for that. Now, and so x here, guys, is sine theta. So the solutions for this, let's go ahead and see what they are. Now we can't factor this. We could try to complete the square, but I guess we can. We're going to end up with fractions. Okay. Or we can use the quadratic formula. So I'll use a quadratic. So that'd be negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. But I have a problem, because right here I'm going to have a negative value underneath the square root. So that means that since this guy has no real solutions, then this guy also has no real solutions. So let's check that on our calculator. So what I want to do here is we'll change our equations here. So I've got cosine. I think I do that every time, right? So cosine squared plus sine. Okay, and I want to know, when is that guy equal to a height of 2? And so what I'm going to do, go to my window here, so between 0 and 2 pi, well, we can go by whatever we want. Let's just do pi over 4. It's going to be irrelevant. And let's do a minimum of -1 to a maximum of 3. The reason I'm going from -1 to 3 is because I want it to be at a height of 2. So if I graph, here's the function, and you'll see that it's never at a height of 2. So my cosine squared plus sine always is going to fall below a height value of 2. So for this, we say that there are no solutions.